All right, picking up where we left off on number 11. This is a single trig function, so I'm going to isolate it. So cosine squared of x over 2 is equal to 3/4. And then we square root both sides. So because we've introduced the square root, we need to have a plus or minus, and then it's radical 3 over 2. So the plus or minus means that you're in all four quadrants. And the reference angle that makes cosine equal to radical 3 over 2 is pi over 6. So remember how we have to do this if we have a different angle other than x? We need to say x over 2 equals pi over 6 plus 2 pi k. So you add in the 2 pi k here. And then if you're going to solve for that, that means that when you multiply by 2, because in this case I want to get rid of that x, the multiplying by 2 affects both the angle and the k term. So the final answer for x is 2 pi over 6, which you have to reduce. Always simplify to get full credit for AP Pre-Calc. So 2 pi over 6 is pi over 3 plus 4 pi k, and k has to be an integer. So we're going to do that for all four angles. And I don't try to then apply this to all the other angles because I think it's easy to make a computational error there. So I'm just going to keep saying x over 2 should equal, the next angle is 5 pi over 6 plus 2 pi k. So when you multiply by 2, you're going to get 10 pi over 6, or multiplying by 2, you could say, oh, the 2 over 6 is going to reduce. It's probably better. So 5 pi over 3 plus 4 pi k, where k is an integer. And the next x over 2 will be 7 pi over 6 plus 2 pi k. Now, if you can generate all of these angles by just not having to write this part down, that's fine with me. I just think I like to do it this way. So 7 pi over 3 plus 2 pi k. Now let's think about this. 7 pi over 3 plus 2 pi k. Isn't that the same as pi over 3? 7 pi over 3 is coterminal to pi over 3. So do I really need this answer? Probably not. You can still write these out. Next one would be 11 pi over 6 plus 2 pi k. And again, yeah, if we multiply by 2, we're going to get 11 pi over 3 plus 2 pi k. So the general rule here is if you are given angle, if you're generating angles that are more than a full circle, then you should, you don't need to include those. You're already including values where we're generating extra terms. I think, let's see, let's make sure that's right. So if we add 12 pi k to pi over 3, you get 13 pi k over 3. Oh, maybe not. Maybe we do need to still include these. I need to think on that more. If we're just going from 0 to 2 pi, then these are our solutions because we're outside of the 0 to 2 pi realm. But let's see. This would give me like the next, 4 pi k, sorry, 4 pi k. This would give me, let's see, 19 pi k over 3, and I don't think any of these others would give me 19 pi k over 3, so maybe I should have those. I would say better to list them all and have more answers than you need than maybe leave some off. So I'm just going to leave it like that. Let's see. Next one. We have 4 terms. So this was a struggle on the last quiz that we took. When you have 4 terms, even though it's kind of hard to see that there are 4 terms here, you need to factor by grouping. So if we factor by grouping the first 2 terms, we can take out a 2 cosine x. That's a common factor that they both have. And that would leave you with cosecant x minus 2. And then all we can do is take out a minus 1 from the last 2 terms, but that would leave you again with cosecant x minus 2. So factor by grouping allows us to, in this case, factor out a common factor of cosecant x minus 2, and then that would group together 2 cosine x minus 1. So this means cosecant x could equal 2, Now I'm used to thinking in terms of sine, so I'm going to switch this around. That means sine x is equal to 1/2. I'm more used to that. And over here, cosine x is equal to 1/2. So sine is positive in quadrants 1 and 2. The reference angle to make sine 1/2 is pi over 6. So the first two solution sets are pi over 6 plus 2 pi k, where k is an integer. And in quadrant 2, 5 pi over 6 plus 2 pi k, where k is an integer. Right? All right, and then over here, cosine is positive in quadrants 1 and 4. The reference angle that makes cosine 1/2, well, it can't be pi over 6 because that made sine 1/2, so it's pi over 3. And we've got x equals pi over 3 plus 2 pi k, where k is an integer. And x equals, in quadrant 4, 5 pi over 3 plus 2 pi k, where k is an integer. For problem number 13, this looks like a trinomial, but first I need to get everything on the same side. So I'm going to keep the squared term positive. That's how I prefer to factor. I'm going to subtract cosecant x and subtract 2. So that lets me factor this into cosecant x and cosecant x. 2 has to get split up with 2 and 1, or 1 and 2, doesn't matter. And then you need the 2 to be negative and the 1 to be positive so that this adds up to negative 2 cosecant x plus cosecant x. That gives me the negative in the middle. This means that cosecant x could equal 2, or cosecant x could equal negative 1. I'm going to rewrite those in terms of sine. That means that sine x could equal 1/2, or sine x could equal negative 1 as the reciprocal of negative 1. Now we just solved for sine x equaling 1/2 in the previous problem. So if you're confused about how to do that, go back to this one, quadrants 1 and 2, reference angle pi over 6. My answers are pi over 6 plus 2 pi k, where k is an integer, and 5 pi over 6 plus 2 pi k, where k is an integer. So we got that. When is sine equal to negative 1? That's only at the bottom of the unit circle where we have a y-coordinate of negative 1. Everywhere else, sine is 0 or positive 1. So this is 3 pi over 2 plus 2 pi k, where k is an integer. All right, and number 14, we're back to a single trig function. So let's isolate it. Tangent squared of 2x equals 1/3. We need to square root both sides, which generates a plus or minus. So tangent of 2x is equal to plus or minus square root of 1 is 1. Radical 3 will leave that way. I do not rationalize this. I'm just thinking on my unit circle, I've got these two options. Here's the pi over 6 coordinate, and here is the pi over 3 coordinate. So which one of these gives me a y over x of 1 over radical 3? That's a reference angle of pi over 6. It's this one. Okay, so again, this is 2x. So we're going to have to say 2x is equal to pi over 6 plus 2 pi k. And then when we solve that for x, we're dividing by 2 this time. Dividing by 2 is the same as multiplying by 1/2. I like to show it like that so I don't mess up my fraction work. So x is equal to pi over 12 plus 1 pi k, which is pi k because 2 times 1/2, and k is an integer. And then again, I do this for all four. So 2x is equal to 5 pi over 6 plus 2 pi k. So x is equal to 5 pi over 12 plus pi k. And 2x equals 7 pi over 6 plus 2 pi k. X is equal to 7 pi over 12. Notice that we're not even in, like, this gets me to, I'm finally into the second quadrant. 7 pi over 12 is just past 1/2 pi. And finally, 2x equals 11 pi over 6 plus 2 pi k. X equals 11 pi over 12, so you're just short of 1 pi plus pi k. But remember, the plus pi k part, if we had to say generate all of the answers between 0 and 2 pi, we can do that just by continuing. Like here are the first 4 sets of answers when k is 0. We would get another set of answers when k is 1, another set of answers when k is 2. So we would just keep going until we get something that's past 2 pi, which would be like past 24 pi over 12. All right, now what about inequalities? So our inequalities for our test, we're going to solve just on the interval 0 to 2 pi. You saw in AP Classroom, sometimes they adjust this a little bit. But for those multiple choice questions, a lot of times if you're given a set of intervals, you can just get right down to the testing part. So it's kind of nice. Number 15, tangent is already isolated. Remember, with tangent and with cotangent, you need to include not only the values that make tangent equal to -1 or cotangent equal to 1, you also need to include the values where tangent and cotangent are undefined. So tangent x is equal to 1 in quadrants 2, equal to -1 in quadrants 2 and 4. The reference angle is pi over 4. So the first two critical numbers that we get are x equals 3 pi over 4 and 7 pi over 4. And because we're on the interval 0 to 2 pi, we're not adding 2 pi k to those. We also need to consider where is tangent x undefined so that we don't include sets of values for x in our solution set that shouldn't be there. Basically, I don't want to shade more than I'm supposed to shade. All right, tangent is undefined at pi over 2 and 3 pi over 2. You need to know the pi over 2 thing. We see that a lot. We graphed with that a lot. And in calculus next year, when we do limits, you'll need to know that the tangent graph is unbounded at pi over 2. All right, so all of these would go on a number line. Now, like I said before, I like to also, besides just a number line, I like to use the unit circle. You could just use a unit circle. You could just use a number line. You've got to have something to show that you're testing intervals and you're not just wildly guessing what the answers should fall between. All right, so what do I mean by that? Well, I plot these angles both on the unit circle and on the number line. So what's the first angle I hit after 0? That would be pi over 2. That's an asymptote, so it's open circle. Next one would be 3 pi over 4. Now 3 pi over 4 is not an asymptote. It's where tangent equals -1. So closed circle for that because we're allowed to equal -1 in this problem. And then we would hit 3 pi over 2. And then we would hit 7 pi over 4. 3 pi over 2 is a vertical asymptote. And 7 pi over 4 is when we're equal to -1. So that's why I colored those accordingly. If you're having trouble with placing those in the correct order, try using the circle first. So we're starting at 0, pi over 2, and then we hit 3 pi over 4, which is right here. And then we go down to 3 pi over 2, and then 7 pi over 4. So the unit circle helps me correctly pick values that are between these angles. I find that that can be kind of difficult if I'm just looking at this in a linear fashion. So remember, as long as it's not undefined, you can plug in 0. 0 is included in our solution set anyway, so we can test 0 for this first interval. Tangent of 0 is greater than or equal to -1. We're checking for true or false statements here. So tangent of 0 is 0, which is greater than or equal to -1. That's true. So we're going to shade this first solution set. And then we check in here, something between pi over 2 and 3 pi over 4. So I can see more clearly on my unit circle that the only nice common angle I have up there is 2 pi over 3. So tangent of 2 pi over 3, is that greater than or equal to -1? Well, I know it's negative because we're in quadrant 2. So if I knew tangent was positive, I'd say true. What is the coordinate at pi over 3? The coordinate at pi over 3 is negative 1/2 radical 3 over 2. So tangent is negative radical 3, and that is that is not greater than or equal to negative 1. Be careful with negatives. If this is negative 1 point something, that's a smaller number because it's more negative than negative 1. So that is not a solution. It is true that these often alternate, but you want to check and be sure. And I'm not sure how much work, if this made it into a free response question, not sure how much work we would be required to show for this. What's between 3 pi over 4 and 3 pi over 2? I would pick pi. That's a nice one to plug in. Tangent of pi, is that greater than or equal to negative 1? Yes, because that's 0 again. So tangent 0 is greater than negative 1. So here's another solution set. And then in here, something between 3 pi over 2 and 7 pi over 4. The only nice answer we have in there is 5 pi over 3. It should be the same type, like an over pi over 3 angle that you chose for the other section. So tangent of 5 pi over 3 is also negative radical 3. And so this is still a false statement. And so it's probably true here. We can plug in 2 pi, and that would be the same result, right? Tangent of 2 pi is greater than or equal to negative 1. That's back to 0. So this section is a solution as well. So this has, let's see, we've got to watch our brackets here. So 0 is closed because it's closed here. And this, we had a true statement when we did plug in 0. So 0 to pi over 2, not including pi over 2. That's where tangent's undefined. And then including 3 pi over 4 to 3 pi over 2, not including, that's a vertical asymptote. And then from 7 pi over 4 to 2 pi, not including 2 pi only because the interval says not to in the directions. All right, now remember, I said this when we did the notes in class. Tangent and cotangent, those are the hardest problems because they have undefined values. If you have sine or cosine, these should be pretty quick because we don't have as many undefined values. So remember, the steps are to isolate the trig function first. So add 1, divide by 2. Find the critical numbers. So cosine is positive in quadrants 1 and 4. The reference angle to use is pi over 3. That's what makes cosine 1/2. And so our x values are pi over 3 and 5 pi over 3. So if we're putting those on a number line, we're still going from 0 to 2 pi. Pi over 3 with an open circle since it's less than is somewhere over here. 5 pi over 3 is somewhere over here. And you may not need a unit circle for this one, but I'm just going to draw one again, just in case you do. So here's 0, here's pi over 3, here's 5 pi over 3. So we have lots of range here, options, I should say, to plug in. So first value I can plug in is 0. I can say right here, is cosine of 0 less than 1/2? Cosine of 0 is 1, which is not less than 1/2. So nothing in that first solution set. Anything between pi over 3 and 5 pi over 3, I would pick pi. So is cosine of pi less than 1/2? Yeah, cosine is negative on this entire interval between the quadrants. And then any of these values between the pi over 2s and the pi over 3 angles would also create a true statement. So -1 is less than 1/2. That's true. So everything in there works. This is probably false. We can double check that by saying, well, we're in quadrant 4. And if we plug in anything past where cosine is equal to 1/2, it's just going to get larger. Or you could just say cosine of 2 pi, is that greater than 1/2? Oh, sorry, not greater. Less than 1/2. 1 is not less than 1/2, so that's false. So our only solution set for this one is pi over 3 to 5 pi over 3. All right, for number 17, if you have this problem with cosine and sine, we did this in a couple of homeworks. we need to compare their graphs. That's the easiest thing to do so that you don't have a bunch of algebra that you're testing. So let's just graph both of these functions. We should be able to do this pretty easily. We spent a long time graphing sine and cosine. They both have a period of 2 pi. We can cut that period into 4 equal parts. And we know that both graphs have a max of 1 and a min of -1. So let's say the cosine graph is going to be blue and the sine graph is going to be red. So cosine begins at 1, then 0, -1, 0, 1. So here's the cosine graph on 0 to 2 pi. The sine graph starts at 0 and then goes up to 1, 0, -1, 0. I'm putting them on the same graph, on the same axis, because I want to compare where one graph is above the other. So I want blue to be above red. So that happens right here on this little interval. Where do they cross? Pi over 4. They're both equal to radical 2 over 2 right there. Blue is also above red right here to here. What is this point? It's between pi and 3 pi over 2. So it's down here in quadrant 3. At 5 pi over 4, both sine and cosine are negative radical 2 over 2. All right, so our solution set, this is greater than or equal to. So we're going to include the points 0 to pi over 4, include both of those endpoints, and then include 5 pi over 4 to 2 pi. And the only reason I'm not including 2 pi is back to the directions. We're just looking at the interval 0 up to 2 pi, but not including. All right, we're ending on, again, another like slightly difficult one. We've got cotangent. So first isolate it, divide by 2. When is cotangent less than 1? So cotangent is less than 1. I need to consider what makes cotangent equal to 1. So that happens in quadrants 1 and 3. And the reference angle is pi over 4. So x equals pi over 4. And in quadrant 3, 5 pi over 4. Also, you have to think about where's cotangent undefined. Cotangent has asymptotes at 0 and pi. So all of these get to go on a number line. So 0 to 2 pi. We're not including 0 this time. We're not going to be able to test that one. We would hit pi over 4 with an open circle because it's less than. And then we would hit pi somewhere here and 5 pi over 4. I'm going to use my little unit circle to organize my work here. So we've got 0, we got pi over 4, got pi, and 5 pi over 4. Oops, 5 pi over 4. I'm going to want to put that in the correct quadrant. It's in quadrant 3. All right, so we have a better visual of which angles fall between those critical numbers. So normally I begin by plugging in 0, but I can't do that here. So instead of 0, I'm going to pick pi over 6. I can't do that because cotangent of 0 is undefined. And I don't know, is undefined less than 1? That's kind of hard to say. So sorry about that. Okay, so for pi over 6, I'm going to do cotangent of pi over 6 is less than 1. So what is the cotangent of pi over 6? You might need to remind yourself what that ordered pair is. Nothing wrong with that. X over y is radical 3. Is radical 3 less than 1? No, that's false. 1 point something is not less than 1. So nothing in that section. What about between pi over 4 and pi? I would pick pi over 2. I like to pick those non-quadrant angles anytime I can because then I'm working with zeros or ones or negative ones. So what is the cotangent of pi over 2? Cotangent of pi over 2 is 0. That is less than 1. That's true. So everything in that section should work. And then between pi and 5 pi over 4, the only nice angle we have there really is 7 pi over 6. Remember, it should match up to what you picked on the other side of that. Cotangent of 7 pi over 6 is positive, again, radical 3. So positive radical 3 is not less than 1. Same result I got for the other pi over 6. And then finally, something between 5 pi over 4 and 2 pi, I would pick 3 pi over 2. So the cotangent of 3 pi over 2, is that less than 1? Well, that's 0 again. That is less than 1. So there's our solution set. So our solutions for this one, all parentheses because we have plain less than, pi over 4 to pi, and 5 pi over 4 to 2 pi. All right, that finishes off that section.